We can now move on to part C. So starting with number 1 again. So these are the 5-point questions. Sige. Start now.
Hello everyone again. So the first question of part 3 is a geometry question. So it says that we have a triangle ABC, and then we have 3 diameters, and you want to find the area of this hexagon that I've already drawn here. So a lot of people actually got this correct. So uh, the answer here is uh, the answer here is twice the area of ABC, or 168. You can kind of look at this and see that these shapes can kind of be folded in to create the original triangle. So uh so yeah, if you want to um actually show this, you can either just find the lengths. So like using trigonometry or some other method, you can find the areas of these 3 triangles, but I'll show another way. Yeah. So, um, yeah, first of all, so I'll just introduce um a config that will help us prove this. So I'm gonna write in the right side of this board, right side of this figure. So if we have a circle and we have a triangle here with vertices A, B, C, and we have the orthocenter here, and we have a parallelogram. So let's say like this. Um, so if you create a parallelogram for BHC, this point is let's say that's um P. So this point is actually in not only on the circle, but also a diameter. This is a diameter of the circle. Uh, so okay. So if you know second quadrilaterals, the opposite side, yeah, I already said this before. Opposite angles of a second quadrilateral add up to 180 degrees. So okay, anyway, so first of all, what's angle BHC? So if we just have the altitudes real quick, this one here. So this is so okay. So I'm just gonna call these angles ABC. So this is angle C. So this is 90 minus C, and this one is also. Oh wait, never mind. Wait, we're gonna do that. We're gonna do this. So here's another way. So this is angle A, right? So we have angle A here, and this is a quadrilateral. So this is 180 minus A. So by vertical angles, this is also 180 minus A. And since this is a parallelogram, BHCP, we're gonna have this as also 180 minus A. So we have here that two angles are opposite to each other and add up to 180 degrees. So we have P lies on the circle. Next step is to prove that AP is a diameter. So to prove that, we just need to show that this is a right angle. This is a right angle. Because if you prove that's a right angle, this is a diameter already. So okay, so since this is a parallelogram, this angle here is the same as this angle here. And we know that this is angle B, and we have this is a right angle. So that's 90 minus B. And we have this to be 90 minus B also. So just adding them up, we get 90 degrees. So then this is a diameter. So how can we use the fact that this if we have a diameter AP, we create a parallelogram with the orthocenter H. So this is a fun thing to explore. Another thing to explore is that okay, so P is the reflection of H to the midpoint of BC. Another thing to explore is that if you reflect H of the side BC, it's gonna land on the circumcircle also. So here. Anyway, so let's go back here. So in this original diagram, if we have H, the orthocenter, we have three sets of parallelograms. So we have AHBC prime here, AHCB prime here, and HBCA prime here. And because they're parallelograms, these are parallelograms. This triangle here is the same as this triangle right here. They have the same area, and they're congruent. They're congruent triangles, so they have the same area. Next one is these two triangles here are also the same area. Finally, these two triangles here have the same area. So there we go. Wait, actually, I'll like label these with like that's one, one, two, two, three, three. And so we have we basically just split the triangle up and just reflected it with parallelogram. So the hexagon, the total area of the hexagon is just twice the area of the area of the triangle. So if you have any questions, just put in chat na lang. So yeah, that's it for problem 1.
Okay, do we have any questions for number 1? Yeah, I think people can meta solve this by considering like a ABC like solving the problem where ABC is equilateral and then guess that it's twice the area. But here we present the actual solution. Do you have any questions? If none, let's go to number 2. Oh, yeah, it's the special triangle. So 13, 14, 15 has height 12. So that's the height to the side with length 14.